Hello, in this video, I just want to do a couple more linear approximation examples. Let's get started. This first one, I want to find the equation of a tangent line. Find the equation of the tangent line to the function, and I'm going to pick a function that lots of people forget about the derivative of. Let's say f of x equals log base 3 of 4x squared minus 1. Find the equation of the tangent line to that function at, let's say, x equals -1. Okay, and so I'm choosing this example again because this function is one many forget the derivative of. And so the equation of the tangent line, we better start with the slope of the tangent line first, which means we need f prime of x. So the derivative of log base 3 is 1 over the natural log of 3, the base, times 1 over the argument, 4x squared minus 1. But then we have to multiply by the derivative of the inside because of the chain rule, so that's times 8x. Now, we want to find the slope. So for the slope, we need to evaluate this derivative formula at x equals -1. So we'll evaluate the first derivative at x equals -1, and we can indicate that by drawing a vertical line next to the expression we want to evaluate. And so we'll evaluate this expression at x equals -1 as well. And so what we get is 8 times -1 is -8. On the bottom, we've got the natural log of 3 times -1 squared is 4, or sorry, -1 squared is 1, times 4 is 4, minus 1 is 3. So actually we get a denominator of 3 natural log of 3, and that's our slope. So now we need the equation of the line, and for the equation of the line, we need the slope and a point. Well, x equals -1 is just an x value, so we need a y value on this curve. So if we plug in -1 for x, 4 minus 1 is 3, log base 3 of 3 is 1, because 3 to the first power is 3. So our point is -1, 1. So now the equation of the line is y minus, let's call this y1, let's call this x1, y minus y1, so y minus 1 equals our slope, -8 over 3 natural log of 3, times the quantity x minus x1, so x minus -1 is x plus 1. And now we just want to put this in slope-intercept form by getting y by itself. So we'll distribute our slope, which is an ugly number, but it's just a number. So -8 over 3 natural log of 3 times x minus 8 over 3 natural log of 3. Last, we'll add 1 to get y by itself. So we have our slope, -8 over 3 natural log of 3 times x. And then our constant, I'm going to kind of separate it so it looks like mx plus b. Our constant is -8 over 3 natural log of 3 plus 1 is our new constant. So our slope is -8 over 3 natural log of 3, and our b in the mx plus b equation is -8 over 3 natural log of 3 plus 1. And that is the equation of the tangent line to this function at that point. Okay, so let's do another where we actually use a tangent line or a linear approximation to approximate the value or the output of a function. Use a linear approximation to approximate the value of the cube root of 1 minus 0.001. Okay, so here it's kind of up to us to build all the components we need to do this approximation. We're looking for in a linear approximation, we're looking for formula mx plus b to approximate some curve that's not a line, some function. So the first thing we need to do is use this expression to create a function. So let f of x equal the cube root, let's say, of 1 minus x, because the point 0, 0, 1 looks like the thing that we want to plug in for x. And we want to consider this near a nice point close to when x is 0.001. Well, we'll do that whenever x equals 0, because this function behaves really nicely at 0. And this x value here is close to 0. So we're going to find the tangent line first to get our linear approximation, which means we need the slope. So the slope will be f prime of x, but evaluated at x equals 0. So f prime of x, we have to take the derivative of the function 1 minus x to the 1/3 power, since it's a cube root. So f prime of x will be 1/3 times 1 minus x, subtract 1 from the exponent, and multiply by the derivative of 1 minus x, which is just 0 minus 1, or -1. So all I have to do is multiply by -1. So that's my derivative, and I need to evaluate that now at x equals 0 to get my slope. So 1 minus 0 is 1, to the -2/3 power is 1, times -1/3 is a slope of -1/3. Now we need the line, which means we need a slope and a point. So we need the y value that goes with x equals 0 in the function. So we plug 0 in for x, and we get the cube root of 1, which is 1. So that is our x1 and y1 that we'll use in our point slope formula. So the line is y minus y1, which is 1, equals m, -1/3, times x minus x1, which is 0. These could also be x naught and y naught, whatever you like there. So distribute the -1/3 and add the 1, do some basic algebra here, and this is our linear approximation. So now we can see our conclusion is that the original function, the cube root of 1 minus x, is approximately equal to, this cube root curve is approximately equal to the line -1/3 x plus 1 when x is near 0. So it only happens if x is close to 0. So now how can we use this to approximate this value? Well, if I want to know the cube root of 1 minus 0.001, then I'm going to plug in 0.001 for x. I know that will be -1/3 times 0.001 plus 1. Which on a calculator gives us 0.999, and then I've got 5 6s, and it rounds that last digit up to a 7. So now we've got a cube root of 1 minus 0.001, which, by the way, is the same thing as the cube root of 0.999. That's going to be approximately equal to this value, which is not difficult to calculate with a calculator. You could even write -1/3 times 0.001 plus 1 as a fraction. We could do that real quick. If you don't want to use a calculator at all, you could say 0.001 is 1/1000th. So you get -1/3 times 1/1000th plus 1. So we get -1/3000 plus 1 is 3,000 over 3,000, which gives us 2,999 over 3,000. So I actually kind of like this answer better than the decimal approximation, but either one is okay. The key is understanding that you've got to build a function near a nice x value to generate a tangent line that behaves similar to the curve at an x value that's close to what you want. Okay, so I hope this video helps with that concept.